Okay, I'm going to work through a spotting model nomogram. This is to determine the maximum spotting distance from a torching tree. Our inputs that we are given is the height of the torching tree, which is 150 feet, tree species, which is going to be a grand fir in this case, the diameter base height, 20 inches. The average tree cover where the embers are going to fall will be 130 feet, and then the 20-foot wind speed, we have 20 miles per hour. So basically, we're just going to work across these lines and fill these boxes as we go. The first box here, box D, we just get that by taking half of the torching tree height. So A divided by 2. So 150 divided by 2 is going to be 75. Now we're going to use that number later on when we punch that into our maximum firebrand height. So now we go down to the next line, the tree species, and we're looking for the flame height. The inputs for the flame height are going to be the tree species and the diameter base height. The diameter base height, as that changes, the larger the diameter base height, the assumption is there's more vegetation on the tree that is available to burn, and as well as the species, the grand fir and the firs and spruces tend to have much more vegetation than the pines, lodgepole, or other pines. So for this B, we're going to take these two inputs and put them into our first nomogram. We need diameter base height, which we have here of 20, and then we need our turn line. So we're going to use this one here, diameter base height of 20, and then it's a grand fir, so we'll use this line. So we start down here at 20, come up to our turn line, and across. And that brings us in here, 70, just below 80, so at about 77. So we'll punch in 77-foot flames. So we've got a 77-foot flames. Our next box is the ratio of the tree height to the flame height. So how big are these flames compared to the tree? And that's just A divided by B, which is the tree height divided by the flame height. So 150 feet. Oops, not times. 150 feet divided by 77, 1.94, so we'll round it to 1.9. So the flame heights are just about half, more than half of the height of the tree. So for C here, we need two inputs. We need the ratio of the height of the flame, and then we need the flame duration. So to get the flame duration, we're going to use the inputs of the tree type and the diameter base height here, and we'll go to model nomogram number 2. Okay, so again, we have a 20-inch diameter base height, and we're going to go up to the grand fir turn line right there, and we'll take it across. Looks right at 4.5. So we can punch that in as 4.5 as our flame duration. So we got the flame duration and the ratio of the tree height to flame height. We can fill in C. We can punch those numbers into nomogram number 3 to get our block C, the ratio of the lofted firebrand height to the flame height. Okay, so for this one, we want the flame duration, which we know is 4.5, so we'll go right here. And then we want the ratio of the tree height to the flame height, 1.9. We don't need that 4 there. So 1.9. So if it was 0 to 0.5, we would use this line as our turn line. 5 to 1.0, this line. 1.0 to 1.5 here. And then if it's over more than 1.5, we use the dash line. In our case, it's 1.9, so we're going to go all the way up to the dash line. So there we go. Hit our dash line right there, and then we're going to go across. That gives us right at 7. So There we go. 7 is our ratio of lofted firebrand height to the flame height. Now to get box E, we just multiply the flame height times that ratio that we just got, and that gives us E. So 77 times 7 is 539. So that is how high these firebrands will loft off the tree. Now, to get our maximum firebrand, we're going to add half the height of the tree, with the idea being that if the firebrands are ignited and they start lofting from somewhere on the tree, probably halfway up to the top, it accounts for that part of the tree. So we'll add 75 to that. And that's going to give us our maximum loft height. Okay, now we know how high they're going to loft. We need to figure out how far they're going to go. So we're going to consider the tree cover that they're going to fall into. If it's tall trees, the ember will have less time before it hits some sort of obstruction before it hits the ground. If there's no tree cover, it has all that time that is being blown with the wind to land on the ground. So it can get a little further distance. So the taller your tree cover, the less spotting distance you generally are going to have. So the effective tree height, if you're in a dense stand, you're just going to use the average tree height. Now, if it's an open stand, you're going to take half of that with the idea that it could fall into the open earlier. But we're going to say this is a dense stand, and it's going to be 130. We'll just punch that in there. Okay, now to get the treetop wind. So we've got the 20-foot winds above the trees. It's going to be 20 miles per hour. At the treetops, it's going to be about 2/3 of that. So we got 20 mile an hour wind times 0.666. And that's going to give us 13 mile per hour wind. All right, so now the effective tree height and the wind that's going to carry our firebrand that can loft up to 614 feet, we want to see how far away it as the maximum it can spot. And that's going to be within the fourth and last nomogram. This one takes the maximum firebrand height, which is 614. So it's probably around in here somewhere. And then the effective tree cover height, which is 130. So this is our 200 mark. This is our 100. 150 would be in here. So probably right in here or so would be our 130 mark. That's going to be our turn line. We also, the next turn line is going to be the treetop wind, which is 13. So this is 10 and this is 15. 13 is probably going to be in here somewhere. So we just draw a line there, and there's our turn line there. Okay. Come down here at our maximum firebrand height. We're going to go up to this turn line right there. 130 foot tree cover. We'll go over to our 13 mile an hour treetop wind and then down, and that looks like it's going to put us at here's half a mile, so 3.5 tenths of a mile. So 0.35 tenths of a mile is going to be our maximum spotting distance for this tree with these winds.